questions do we want to see? Do we go over on the shark bite? A lot of 4s and 5s, and then I think I saw more 1s than anything else. So we'll do those 3. One can be done in Desmos a couple different ways. You can either put in each one with a number using parentheses. You can put each one in using the sliders. If you capitalize the X and the Y, so I'll do that. And then I want to add in all my sliders, change my X to be 4. Okay. Y to be 10, and Z to be 2. And then it will give me my answer of 3. If you have put in each number where each variable is using parentheses, you also would have got 3. So B was our answer there. If you're not doing it algebraically, make sure you're saying use Desmos or the calculator. Questions there? Okay. Number 4, you need your line of best fit. So you need to put in your table. And then when you get to the SL, if you blank, always try to remember your equation of a line, y equals mx plus b, and just change the y to y1, the x to x1, and then the equals to the tilde. Because again, this will be something not given to you on the SL. And then round to 3 decimal places, so 1.623x plus, that's all, I typed in something. Maybe that was it. Maybe that was a different one. Okay.
My graph doesn't look like that, but I still got the same answer.
Okay. I hit the plus that was next to this. So 1.623x, y equals, and then plus 14.815. So make sure you have that line of best fit. Questions there? And then number 5 can be done in Desmos. So negative 2x plus 8 less than or equal to 18. It's going to give you a vertical line that's solid, so that would be closed on your number line. At negative 5, going to the right. So it would be x is greater than or equal to negative 5. Put negative 5 on your number line. Make a closed circle going to the right. Questions there? On the test now, I'm going to show you the answers, and then if there are any we want to see by hand or in Desmos, we can go over those. So number 8 was 8 times the square root of 6. We're actually going to be talking about how you would get something like number 8 today. 9, the equation has no solutions, was the only one you should have circled. 10, I have the answer for the packet, but I also have the answer if you were on the app or on your computer. So on the paper, the answer was C, but if you were on your computer or on the app, the question is different, and the solutions are 1 and negative 3. And then when you're ready, go on to the next page. $11 was x is greater than negative 9, or you can write it the other way, negative 9 is less than x. And then with 12, you needed this ray put on the number line at negative 4 going to the left. And then 13 was C. And 14, the region was 2. Are there any of those we have questions on when it's C by hand or in decimals? Numbers 15 through 21 is due next Tuesday. Yes. Say how you got that is the 13. So in this example, we have some 750 during the day. Let's call that X. And 1250 at night. I'm going to be adding those two together. At least is greater than or equal to 300 not and then you can do one or two things. One, eliminate the ones that are less than. So it has to be C or D. And then I could solve both of these for X and Y. We got 40 for X. Which is where it crosses. And then if I did the same thing, divide both of these by 1250. We get 24, which is in between the 20 and the 30. And if we did that here, it's backwards. Other test questions. Okay. So today, look at your notes. We're going to do the last section in Unit 11, and then Wednesday we're going to move on to Unit 12 to be done with Unit 12 by Tuesday. But Unit 12 is probably the easiest one. So we are going to deal with radical operations today, starting with adding and subtracting. When you look at or see a problem where we're adding or subtracting radicals, you want to simplify all the radicals as much as possible, if possible. And then when you add or subtract radicals, you have to think about these like combining like terms. You can only add or subtract radicals with the same index, so the same number on the outside, and the same number inside, the same radical. So for this example, I could simplify the square root of 20 by, let's just do perfect squares. What's the highest perfect square that goes into 20? 4, and then 4 times what would give us 20?
5.
And if I broke down the square root of 4, we know that's 2. So all of these are next to each other, so we're multiplying. So negative 2 times 2 times the square root of 5 minus 2 times the square root of 5. Multiply negative 4, negative 2, and 2, we get negative 4. And then here, since these are as simplified as possible, you can combine these, but you're not going to combine what's inside the radical, just what's outside, the coefficients. So this would be negative 6 root 5, or negative 6 times the square root of 5. All of these can be checked in your calculator or in Desmos to find the decimals. So in a second, I will put that in to show that. Since I already have it up here. So if I type in the original and I type in my final answer, the decimals match. And I know that's how I know that works. Any questions on that process before we continue? Subtract these. So then, what would the answer be for number 1? Number 1.
1 6.
1 times the square root of 6, or just root 6, the square root of 6, because 6 can't be simplified more. What about number 2?
4 root square root of 5.
4 times the square root of 5, or 4 root 5. And then some of the other problems are just going to be more simplifying. So look at numbers 3 through 8. Find any you want to see, you go over and have questions about.
7 and 8.
And that's good enough. So starting with number 6, we're going to simplify both. I'm going to do this simultaneously. What is the highest perfect square that goes into 28? So you're thinking what can be divided by 28? Not the closest perfect square to it. 4 and 7. Mm-hmm. And then what's the highest perfect square that goes into 112? So then if we break down the square root of 4, the square root of 16, we have negative 4 times 2 root 7 plus 4 times 4 root 7. Multiply both. Negative 8 root 7 plus 16 root 7. Now we have the same radicand. Combine those. What would our final answer be? 8. What's the rest?
Root 7.
Root 7 or times the square root of 7, yes. Do you have any questions on that one? Alright, let's try 7. What is the highest perfect square that goes into 160? And 10. And then the highest perfect square that goes into 90.
9.
And then I can take the square root of 16 and the square root of 9. So we have negative 4 times 4, root 10, minus 2 times 3, root 10. So negative 16, root 10, minus 6, root 10. And that final answer would be questions there? Okay. And then last one on this page. Again, let's simplify both. What's the highest perfect square that goes into 45?
9 and 5.
Okay, and then for 245.
and 5.
We have 4 times 3 root 5 plus 3 times 7 root 5. 12 root 5 plus 21 root 5 would give us 28. Say that again.
33.
33. Okay. All of these can be checked in decimals in your calculator too, so if you ever get something where you're adding and subtracting, double check it. Make sure your decimals match. Go on to the next page. Nine through 16 are similar. There are just more of them. Which of those do we want to see you go over half questions wrong?
So 9 through 16.
9 through 16. Which one? 13. Sure.
11.
14.
14. We'll do those three, and then we're going to do one of the applications. Alright, so in 13, be careful, just watch out for all your numbers, make sure you're keeping track of all your numbers. What is the highest perfect square that goes into 8?
2 and 4.
4. What about 45?
9 and 5.
9 and 5. What about 200?
20 and 10.
Those work, but neither of them are perfect squares.
Hundred.
132. Yep. So we have negative 4 times 2 root 2 plus 2 times 3 root 5 plus 3 times 10 root 2. And then simplify each piece. Negative 10 root 2 plus 6 root 5 plus 30 root 2. One of these is not like the other two. We would not add that one. That one would just stay by itself. So we can combine these two to be 20 root 2, and we would just bring the other one down. especially if you have a lot of radical pieces, double check it in your calculator, make sure your decimals match. Do you have any questions there? Right. For the next one, can the square root of 6 be simplified?
2 and 3.
Are either of those perfect squares that we could break down? No. So this one's going to stay the same, this 10 root 6. But 150 can be broken down. What is the highest perfect square that goes into that? And then for 54,
9.
6. There we go. So we have 10 root 6 plus 18 times 5 times the square root of 6 minus 4 times 3 times the square root of 6. 18 times 5 would give us
90.
90. Root 6 minus 12 root 6. These all have the same radican, so you can combine them all. 10 plus 90 minus 12 would give us what as our final answer? 88 root 6. In 16, only one of these can be simplified. Which one would that be?
For 8.
The 8, yes. So we're going to bring down negative 3 root 6 minus 5 root 6 plus 4 times the square root of, what's the highest perfect square that goes into 8?
2 and 4.
2 and 4, and then bring down 4 root 2. So we have negative 3 root 6 minus 5 root 6 plus 4 times 2 times the square root of 2 plus 4 times the square root of 2. And then multiply, and then we can simplify. So in this case, we have 2 pairs that can be combined. What would that final answer be?
Negative 8 square root 6 plus 12 square root 2.
12 root 2. So double check the math, make sure you're adding. Do you have any questions there? Okay, we're going to skip 17. Perimeter of a triangle, you would just add up all of these, so it's very similar to what we were just doing. Perimeter of a rectangle, if you want to draw out the rectangle, you can. For our visual people. But in this, you would just have to remember that this is there twice. So what you could do is just simplify each piece and multiply each piece by 2. So it would be 2 times this plus 2 times this. And then we would just have to multiply at the end. So let's do that. Keep bringing down those 2's. What is the highest perfect square that goes into 405?
$81 and 5.
Right. And then for 48,
Eight, 6.
those work, but they're not the highest. have 2 on the outside times our 2 times 9 root 5 plus 2 on the outside times 9 times 4 times root 3. So we have 18 inside, and then 36 inside, and then 36 root 5, and 72 root 3. Perimeter questions or area questions, I would definitely double check the decimals in your calculator or in Desmos. And then once you're ready, go on to the next page. Do we have any questions on that? Now that we've practiced adding and subtracting, now we're going to talk about multiplying. So when you multiply, you're going to focus on just multiplying the coefficients, the numbers outside of the radical together, and then you can multiply the numbers inside the radicals together, the radicands together. So in number 1, there's an invisible 1 on the outside, and then multiply 1 and negative 3. And then multiply 8 and 12. 8 and 2. Sorry, I don't know why I said 12. And then if you can simplify, do that. So the square root of 16 is 4, which would just give us negative 12. So then number 2 would be what?
Negative 6.
Negative root 6, or you can put it as a negative 1 root 6, either or, it doesn't matter. We're going to do 5 or 6. Do we have questions on 3 or 4 that we want to see or do? So multiply the outsides together, multiply the insides together. What would that give us? Times the square root of, and then we just break down 112. What's the highest perfect square that goes into that? So we have negative 8 times 4 root 7. So our final answer would be negative 32 root 7. Yes. Any questions, confusions on how we multiply so far? Now we're going to add variables to the mix, so we have to use our exponent rules with multiplying exponents. So same thing, still multiplying the outsides together, the insides together, so this would be 4 times the square root of 36. When I multiply n squared and n, I would get what?
Into the third.
The third. Then you have to remember how we simplify radicals with variables. So I can break this apart, or you can just leave it. It doesn't matter. I know the square root of 36 is 6. And if I'm using just this method, 2 goes into 3 how many times?
Once.
Once. With how much left over?
1.
1. So that would be 24n times the square root of n. Do you have any questions there? Look at 6, 7, and 8. Are there any others that we want to see you go over, have questions there?
7.
So when we multiply these two together, what would that give us?
Three to the 7.
2 square root of 45.
Square root of 45 w to the 7. And then, if I'm simplifying each piece, what is the highest perfect square that goes into 45?
9 and 5.
And 2 goes into 7 how many times?
3.
3. So that would be w to the 3rd with how much left over? 1. We have 2 times 3. I'm going to move the w to the 3rd to the front. And underneath the radical, 5w. So that our final answer would be 6 w to the 3rd times the square root of 5w. You can put in parentheses here. You don't need them, but you can if you want. Now we're going to do an example where you mix the operations. So sometimes, maybe on the SL, you'll see one where you're adding and multiplying or subtracting and multiplying. And then you have to use your order of operations. So in this, you would multiply first. You multiply these two, what would that give us?
$30 times the square root of 20.
Keep bringing down that minus 6 root 5. We can't combine them right now, but we can simplify the square root of 20. What is the highest perfect square that goes into 20?
4 and 5.
4 and 5. So then we have 60 root 5 minus 6 root 5. And if we combine those, our final answer would be
54 times the square root of 5.
yes. Do we want to see 10? Yes. So then what would we do first there?
Square root of 12x squared times square root of 2x to the 4.
So multiply those. What would that give us? And I'm just going to keep bringing down 7x cubed root 6.
$24x to the 6.
Okay, then we can break that down. Highest perfect square that goes into 24.
4 and 6.
And 2 goes into 6 how many times?
3.
3. So that would just be x to the 3rd, nothing left over. So we have 7x cubed times the square root of 6 plus 2x cubed times the square root of 6. Now we're combining like terms still, but now you're now it's like polynomial operations and radical operations at the same time. Don't combine the exponents. What would that final answer be?
5x3.
You're adding.
8 and 9x cubed times square root of 6.
Yes. So, with the ones with variables in Desmos, check that. Make the variable, if it's x or y, capital. Add in your slider. See if the decimals are the same. If they're just numbers, check it in either. Go on to the next page. So there are 2 more types of multiplying we have to talk about before we talk about the last thing, which is dividing, where we distribute the radicals. So when you distribute, it's just like how you would distribute normal terms, except you have to remember that you're still multiplying outside pieces together and inside pieces together. So when I multiply the square root of 6 to 3, that would be 1 times 3 and then you would just tack on the square root of 6, like if you were multiplying x to something. And then if I multiply the next part, that would be just 1. You can put that or leave it, and then multiply 6 and 8. Then we would break down the square root of 48. What is the highest perfect square that goes into 48?
12 and 4.
12 and 4 work, but it's not the highest. 16 and 3 works. So we have 3 root 6 plus 4 root 3. Can I combine these? They're not like radicals, so that would be your final answer. Do we have any questions on how distributing works? Now we're going to do example 2 where we have 2 binomial sets of radicals. We're doing the same thing. If you would like to use the box method here, that would also work. I'm just going to distribute everything so you see what gets multiplied. So 4 times 2 will just give us 8. 4 times negative root 3, multiply 4 and negative 1, and just bring the root 3 next to it. Root 3 times 2 would give us 2 root 3. And then if I multiply root 3 times negative root 3, what would that give us? Negative 9. So in a lot of the examples where you're multiplying binomial pairs of radicals, one of them is going to be a perfect square. So I'm going to go ahead and change that first, but we'll also have to combine this. And then we could combine the constants and the radical expressions. So if we combine those, what would our final answer be? What's 8 minus 3? 5. And then if I combine these two, what would that be?
6 or
Not negative, not 6, and not, what did you say? Okay, someone else said something. Not negative 8. You're not multiplying, just adding.
6, 3.
Not 6.
10.
Negative 2. Root 3. So you can write it like this, or you can write it with the 5 at the back. But you usually don't see it that way because they don't want you to confuse it and put that underneath the radicals.
So you can simplify it just like that?
That is it, yep. Because these aren't like terms. Have any other questions on this one? Look at the other examples on this page. Which of those do you want to see, do you go over and have questions about?
11 and 14.
17.
11, 14, 7.
Actually, 13.
Which one?
13.
Not 17.
Yeah.
Or still 17.
I mean, if you can do both.
13 is like 14, so let's do 13 instead of 14. And and then so for 11, this would be more like example 1, multiply root 15 to both of these. So this first term would be what?
2 times the square root of 15.
And the second term would be?
Root of 75.
Square root of 15 can't be broken down, but the square root of 75 can. What's the highest perfect square that goes into 75? And yes. So 2 root 15 plus 5 root 3. And that's it. We can't simplify that. And then for 13, you're doing the same thing, but instead of just a number or a radical, it's both. So you're going to take this whole piece, multiply it to both terms, but only multiplying the outside pieces and then the radicals together. So this first term would be negative 6 root 30. The second part would be positive 6 root 18. Can we break down the square root of 30?
No.
No. 30 looks like a number we should be able to break it down because it's pretty high, but 30 is a number that we cannot break down because its factors are 15, 2, 3, and 5. There aren't any pairs. So if you see the square root of 30 in your work somewhere, leave that. But for 18, we can simplify that.
9, 2.
We have negative 6 root 30 plus 6 times 3 times the square root of 2. So our final answer, negative 6 root 30 plus 18 root 2. Yes. Yes. Any questions on how we're distributing so far? For 17, let's do that, and then we're going to move on to dividing. So in this, we're going to multiply 6 root 3 to 5 root 3. What would that be?
Times square root of 9.
And then 6 root 3 times negative 4.
Negative 24 times the square root.
Negative 2 times 5 root 3.
Negative times 3.
And then negative 2 times negative 4 is just positive 8. We can simplify and combine like terms at the same time. What would that be when we combine them?
How to go from 39 to 33?
It's 30 times 3. The square root of 9 is 3. What would that be if we combine them? Root 3, and then plus 8. So we have 90 minus 34 root 3 plus 8. So our final answer would be
856 square root 3.
Say that one more time.
8 and 56 square root of 3.
Combine these
98.
two. Minus 34 root 3. Thank you, Al. Last part, go on to dividing. So there are a couple different ways, Lauren, can you shut that? There are a couple different ways to do dividing. You look at it however you choose to start it and then go from there. So if you have perfect squares, like 49 and 100 are both perfect squares, you can separate this into two different radicals. The square root of 49 over the square root of 100, and then you would just take both. The square root of 49 would be
7.
7, and the square root of 100 would be
10.
10, and that would be your final answer. Done. You might get some where you could simplify. So I know 8 and 32 are not perfect squares, but 8 over 32 could simplify to be what?
1 over 4.
1 over 4. And then I know 1 and 4 are perfect squares, so I could separate those to get 1/2. You might have something that's partially a perfect square, but the other part isn't. So like in number 3, 16 is, but 3 isn't. I still want to separate it. The square root of 3 would just stay the same, but then it would be over 4.
Do you have to keep the radical?
Yes. Yes. You can't drop it off. It would not be the same
Only for this question, right?
for that question. The other ones were perfect squares, that's why we could drop it off. Now, in 4, you could go about it one of two different ways. You'll get the same thing both ways, but one is more work. And then I'll show you how to do some of these. So let's say I wanted to separate it because I know 49 is a perfect square. Then the square root of 49 is 7. So this would just be the square root of 7 over 7. Done. However, if you had chosen to simplify it like you did number 2, the process is going to be a little different. So if we simplified it, what would that give us? 1 over 7. These are 7 is not a perfect square. I'm still going to separate it because I know 1 is. And that would give us 1 over the square root of 7. The issue with doing it this way is we end up with a radical in the denominator. And in math, you won't see that. So to fix that problem, we're going to rationalize the denominator by multiplying the numerator and the denominator by the square root of whatever is in the denominator. So we can do this because of our multiplicative inverse rules. So this would become root 7 over the square root of 49, and then we're back at that same step when we get the same answer.
So we can write down the 1 and 2.
Yes. Now some of them you'll have to do this, but it just depends. Look at numbers 5 through 12. Which of those do we want to see if you go over and have questions about?
9.
8 and 9. Okay, so which one? So each of these you have a choice. Do you want to simplify as is, or do you want to combine them back into one fraction and simplify it that way? So I could rewrite it as the square root of 10 over 45, one big fraction, or we could simplify the square root of 45 and deal with that.
Simplify square root.
If you want to do it the other way, you could also do that. So if we were to simplify the square root of 45, that becomes, what's the highest perfect square that goes over 45?
95.
Okay, so that would become the square root of 10 over 3 root 5. Again, you have a choice. You could combine the 10 and 5 to make one big fraction, or we could rationalize the denominator.
Combine the 10 and 5.
Okay. But if we do that, we have to remember that this is still a fraction. And I'm going to write that as 10 over 5.
Why is it 1 over 3?
Because we're still dividing. There's a visible 1 here. The 3 has to stay in the denominator. So this would simplify to what?
2.
2. So we have 1/3 times the square root of 2. And to put that together, we would have the square root of 2 over 3.
They're both right though, like the first one and then the second one.
When you say the first and the second, we started one way and went a different way, and then that's the final answer.
So 2 over 3 is the final answer.
The root 2 over 3 is the final answer. Now, at each point, you could have done a different choice, and that would have gotten you a different method, but at the end, you should do the same thing. We have other questions on that before we move on to 8. Can 108 be divided by 6?
Yes.
Okay, so do we want to rewrite that as one big fraction, or simplify 108 and deal with root 6? Okay. So we have 7 times the square root of 108 over 6, which you said was what? 18. Now we don't have any more fractions, and we can just take the square root of 18. Highest perfect square that goes into that?
92.
92. We have 7 times 3, root 2. And our final answer would be?
21 and 2.
So that one was probably easier steps. If you had taken the square root of 108 and started to simplify, you may have been able to divide it by 6. You may have had to rationalize it. Right? 9, do we want to simplify as is or make it one big fraction?
One fraction.
Okay. We have 3 times the square root of 5 over 45. What would that simplify to be?
15. No. 45 over 45.
It's 5 over 45. So simplify that.
You got a fraction?
Yes.
So 1 over 9.
Yes. Both of those are perfect squares. So we have 3 times the square root of 1 over the square root of 9, which would be 3 times 1 over 3. You could multiply and simplify, but this is just going to be 1. Also, if you had simplified the square root of 45, you would have gotten 3 root 5, and that would have also become 1. Do you have a question?
I'm just confused.
On
I don't
which
think I
part?
have it. I just didn't get it.
Which part?
Like all of it. I don't
From
that.
which part?
Like the question. Never mind.
Like, did you understand how we wrote this as a fraction?
Yeah.
Okay, so not that part. Do you understand how we got 1/9?
Yes.
So not that part. You're confused here.
Yeah.
Okay. We split this into 2 parts. And simplify each part.
I got you.
12. Do we want to write these as fractions or simplify?
Simplify.
Okay. If we simplify, so 3 and 15 you can simplify regardless, but simplify the square root of 84. What is the highest perfect square that goes into that?
Or 21.
Because 21 is another number that cannot be simplified because it'd be 7 and 3 and that's it. I don't know why I wrote that. Now, if you wanted to break 21 down because there is a root 7, you could do that. Did we want to do that? Leave it as is or break it down to root 7 and root 3. Okay. So we have 3 times 2 times the square root of 21 over 15 root 7. And then this would become 6 root 21 over 15 root 7. So we have a choice again. Do we want to rewrite this as fractions or do we want to rationalize?
Rewrite as fraction.
Okay. So 6 over 15 times the square root of 21 over 7 would simplify to be what?
3.
3 on the inside. What about the outside?
18 or 15.
Divide both by something they have in common.
2, 5.
So then to combine that all, we'd have 2 root 3 over 5. On the back, you will have to rationalize. There may not be a chance to simplify. Look at those and find any questions you want to see. We go over how questions are. This is more fun.
How about for the other question you put 2, then the square root thing instead of 2?
For the last one.
Yeah.
2 times square root of 3.
Because before that you had 2 and 5 square root of 8.
We separated it into fractions, but we need it as one big fraction.
Okay.
Are there any we want to see do go over the questions? The next lesson we do will be shorter than this. You do have multiple things to be working on. You could work on more in this set of notes. This self-math is due Friday, along with and then what we do on Wednesday. You have your test math. You have other self-math, previous self-math. If you haven't done those, be working on something. Use the next 10-ish minutes wisely.